All right, so we're recording. This is the presentation on significant figures, and we're going to go through page 8 of your notes. Okay, if you look at on page 8, you'll see that in bullet point 3, it talks about rules for significant digits. Okay, we just talked about how a significant digit is in theory a way for us to determine how precise the instrument was that took a measurement. In science, it's all about measurements. It's all about what does the measurement tell us. It's also about how precise is that measurement. In a lab, typically speaking, they'll have instruments that can measure very precise. Where might precision come in handy? What kind of government agency? Maybe they send people other places, very far away, you know, into the night sky. What kind of agency might need instruments that are really precise? Airplanes, sure. NASA, yeah, NASA. They have to make sure that their equipment, that their spacecraft is so airtight that when it goes into space, it doesn't implode. Okay, because that's what would happen if it went into space and there was even the tiniest crack and the air was leaking. It would basically implode on itself. Okay, and you basically, you know, all the air would be sucked out of the human body, and the human body would just collapse upon itself, and it would become nothing but a bundle of flesh. Okay, so we have to make sure that when we send humans into space, that our instruments are measuring very precisely. We also have to make sure that when we build buildings, that we're using precise instrumentation. That when we're designing cars, that we're using precise instrumentation. That our measurements are accurate, because if they're not, it can mean the difference between life and death for people. So in industry, it's very important. Maybe some of your parents are engineers. Maybe they work in an automobile, for the automobile company. Okay. I don't know if you guys were paying much attention to the news a couple of years ago, but out in Minneapolis, St. Paul, does anyone know what happened there a couple of years ago? Lily? Wait, I could be wrong. No, just say it. The big Jesus thing? No. Though now I'm really curious about what that is. I'm going to have to look it up. Okay? No, something else. It has to do with a giant structure that crosses the Mississippi River. A bridge. And does anyone know what happened to that bridge? No. It collapsed into the Mississippi River with people on it. Guess who became responsible for that? The engineers, because they didn't make proper measurements and calculations when designing the bridge. When you're an engineer, you put your stamp of approval on things, whether it be a car or a building or a bridge, something that may or may not affect someone's life if it fails. And then they come back and you are responsible. Yeah? Did anybody die or did they all? Yes. They all died? Not all of them, but some did. Okay? All right, so let's take a look at this sig fig business. Okay. Significant figures. There are several rules for significant figures. Those rules really all have to do with zeros, okay? So the primary focus of looking at whether something is significant or not really comes down to looking at zeros. Okay? And, yeah. Now, when we look at zeros, okay, what we're looking for is their placement in a number. Now, the first rule you should all understand is that any non-zero number, yep, say it louder. Is significant. Very good. Any non-zero number is significant. Okay? They're all important. Now, non-zero numbers are our counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? The zeros are the tricky one. Okay? So let's look at a couple of examples of some zeros that you may or may not encounter. And these are actually in your notes if you'd like to take a look. Okay? It's part 4, and there's a bunch of examples there that we're going to go through. Okay, so the first example is looking at 3.2004. A couple things here. First of all, you have several numbers that are significant based on just that first rule that I said. What numbers would be significant here? What do you think? Yeah, the 3, the 2, and the 4. Okay? Those are all significant. However, we have some zeros here. And this is a great rule. It's one of my favorites. If you have zeros, that are caught between significant digits, they're significant. All right, we call these sandwiches. Okay, this one is a mother lode sandwich because there's double O's. Okay, it's like a double Oreo cookie. It's delicious. Despite the fact that it's basically all made up processed, I don't even know what you would be in an Oreo, but it's delicious. Okay, so this is what we call a sandwich. All right, and it means that the zeros are sandwiched between significant digits, okay, or significant figures. You can call it either one. So the sandwich means that the zeros are significant. All right, other sandwiches may or may not include like 303, or 6.01, or 701. Okay, these zeros are all sandwiched between significant figures, therefore they are significant. So when we ask how many significant figures does that number have, in this particular situation, now I'm going to sound weird. Okay, anyway, it has 5. It has 5. So the first significant figure would be this one, and then there's this one, then both of these are significant, then this one. So this one has 5 sig figs, as we call it, or SFs. Okay? All right, next example. We have 0, or actually, let's not do 0. We'll just go 0.002360. Okay, couple things here. First of all, some of these zeros are significant and some are not. Okay? Let's start with the one that is. This 0 right on the very end is significant. And the reason it's significant because it falls into 2 criteria. It is what we call a final 0, means it's at the end of the number, but it also has to be, both of these criteria have to be met after or to the right of the decimal. If it is a final 0 to the right of the decimal, it is significant. Now, you also get zeros like these. Okay, these 2 at the very beginning, this one and this one. These are not significant at all. They're what we call spacing zeros. And spacing zeros are not significant because their sole purpose is literally just to move a number away from the decimal. That's it. Okay? When you have zeros that just move numbers away from the decimal, then they're considered to be not significant, or spacing zeros. This 0 was put here because the instrument that took this measurement was accurate to not the 2, not the 3, not the 6, but to this place right here. Okay? Whereas these 2 zeros, they were just put there to move these numbers down. That's not really significant. They're still important, but they're not significant. They don't tell us anything about the device that took the measurement. So this number would have how many sig figs? 4. Very good. 4 sig figs. I call them sig figs. Yep. Like significant figs. But we're not talking like fig Newtons, even though fig Newtons are pretty awesome because like you have figs, which are like sig figs, this, and Newtons, which are like Newton, like, oh, awesome. Okay? But we're not talking about the cookie, so to speak. Yeah?
Okay, so if there's like, is it only like the 0 that's at the very, very end? Like what if there's like zeros like near the end, but they're not like the very end?
If they're final zeros after a decimal point. So you're asking like if there was a 0 maybe here? If there was a 0 here, it would be significant because it's a sandwich. This one's significant, this one's significant, this one's caught in the middle. It's a sandwich, so that one must also be significant. So it actually falls, you might have multiple rules at play. You might have a sandwich and a final 0 after the decimal point. Okay? Those are some of the harder ones, some of the easy ones. Okay? Let's take a look at these. Let's look at the next one. 1.216 times 10 to the 4th. If you have something in scientific notation, everything out front is significant. Everything. Okay, so if it had been 1.000 times 10 to the 4th, all 4 of these would have been significant. If it's out front, it's significant. That's one of the benefits of scientific notation. One of the benefits is if it's out front, it's significant. So both of these numbers have how many sig figs? Yeah, 4. There's 4 digits out front here. There's 4 digits out front here. If it had been 3 times 10 to the 6th, it would have been one significant figure because there's only one number out in front of the x. Okay, so however many numbers are out in front here, whether they be zeros or not, they're all significant. So scientific notation is really easy. Okay, so the problem in your handout here, the third one down, is going to be 4 sig figs. Okay, the next one, 0.0030. Okay, couple things. Are these two, or even this one, significant? No, they're spacers. Okay, what about this one? It's significant because it's a final zero after or to the right of the decimal point. Okay, notice the exclamation points. Bam, bam, bam. All right, moving on. Let's look at 003.4, which really is not a very good number. Okay, 00, well, first of all, who writes numbers like that? Anyway, let's take a look at it. It would be 003.4. First of all, these ones aren't significant. And these two are. So how many sig figs are there? 2. 2. 2. Okay, moving on. Next. This one would be, what can you guess? 2.1 times 10 to the 9th. 2 sig figs because how many are out front? 2. So it's 2. All right. Oh my goodness. Oh my goodness. It is definitely 6th hour. 3.12000. Oh, 6. 6. First of all, these are give me's. They're not zeros, so they're significant. But these are final zeros after a decimal point, so they all have to be significant. This one for sure, but then these are like a sandwich, so it's like a bam, double whammy sandwich. Okay, with a final zero. Okay, it's everything we come to love in numbers. So there are literally 6 sig figs going on right here. 6 of them. Count them. 1, 2, 3, 4, 5, 6. Okay, 6. Or 1, 2, 3, 4, 5, 6. 6. Lily.
Okay, so for like the ones with like the exponents or whatever.
Sure.
When it's like technically like if you wrote them out like 2.1, 0, 0, 0, 0, 0, like wouldn't those all be significant then if they were all after the decimal point?
Yep.
So then why do we only have 2 significant digits for?
Lily has a very good question. Very, 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 very good question. Let's say we have 2.1 times, I'm going to shorten this one up a little bit. We're not going to go to the 9th because that's a lot of zeros. Let's say 10 squared. Well, that really is the same thing as 210, okay? Now, both of these have 2 sig figs because this is a spacer, okay? And these two are significant. However, let's say that it is, oh, hang on a minute. Let me think about how I could write this. Let's say that it was 2.1 times 10 to the negative. No, that's not going to work either. Lily, the answer to your question basically is when we write the numbers out in front in scientific notation, we're specifying the precision of the instrument. So even though if we were to write it a different way, there'd be more sig figs, we limit it so that it's an accurate representation of what we use to make a measurement. In science, we oftentimes limit it so that we don't have to write a bunch of digits.
So you just don't count the one with the exponent at all? Just the number.
Right. Yep. That's a very good question. Okay. 20,000 is the next one, by the way. And how many sig figs would that one be?
2. Oh wait, where? The decimal?
Well, the decimal in theory would be here, but I'm not going to put it there for a very, very important reason. Chris is right. However, let me explain. If you put 5, I would expect that answer because we haven't talked about this rule yet. This is a new rule. You obviously have a sig fig here, But these zeros, these pesky zeros, are also spacing zeros. They're just on the other side. Notice that there is no decimal, so there is no final zero after a decimal point. They're all before. So they are what we also call spacing zeros. They're spacers. And spacers are not significant. So therefore, there would only be, Chris, how many sig figs? There would only be one significant figure. However, notice how we write the next number. There is a difference. If you write it as 20,000, and then you put 0.0, it's now how many significant figures? It would be 6. And here's why. You now have a final zero after the decimal point. You have this one here. What happens to all these guys in the middle? They're sandwiched. We're talking like the Uber submarine of sandwiches here. Like with all of the meat and the cheese and the lettuce and the tomato, we're talking like the triple-decker Uber like Mancino's like submarine sandwich. Okay? Packed full of greatness and goodness that just happens to come in the form of a zero. Now, if you're still at this point thinking, what? Then here's what you can do. We're going to look at some examples this period, okay? And at this point, we're going to stop the presentation.